Okay, in problem number 3 for Pythagorean theorem, the problem reads, the dimensions and shape of a rectangular volleyball court are shown in this picture. What is the approximate distance of a serve that is hit diagonally from one corner of the court to the other? So the diagram shows that the court is in the shape of a rectangle, and the serve goes from one end to the other end along the diagonal of the rectangle. And as you can see here, we've created two congruent right triangles. So if I draw this right triangle, let me draw the bottom one. How about this? Right triangle looks something like this, where this distance is 9 meters on this side. This distance here, it's one side of the rectangle, so this is 18 meters. And we are trying to find this distance here, because the ball was served from here to here. In the right triangle, this distance is the hypotenuse, which we label as C. Using the Pythagorean theorem, this is the leg, and this is the hypotenuse. We know that the relationship is a squared plus b squared equals c squared. We know that one of the legs is 18 squared plus the other one 9 squared equals c squared. 18 squared is 18 times 18. It is not 18 times 2, which is 324, plus 9 times 9 is 81, which equals c squared. We add these together, and we get 405, which equals c squared. Now, right here, our answer is not 405 meters. That would be a very long distance. We are looking for c, and right now c is not isolated because it is squared with itself. The opposite operation of squaring something is taking the square root of it. So when we do that on the c squared, now we get c. And the square root of 405, which means what number times what number equals 405? Well, I know that if you take the number 400, I know that 20 times 20 is 400, so probably my answer is going to be a little bit more than 20, because 405 is a little bit more than 400. So when I do the square root of 405, I get 20.1 feet if I round to the nearest tenth. So the distance of the serve is 20.1 feet.